I'm Jesse Paris from Rohini College of Engineering and Technology. I'd like to explain about quantum confinement. So here, the nanoscale, the size of material is decreased to reach nanoscale. So there, the same material may demonstrate radically different properties. As the size decreases, the properties also differ. In other words, materials start demonstrating the size dependence properties after reaching the nano dimensions. So this happened because matter at nanoscale does not follow the Newtonian principle and quantum mechanics needs to be applied. How small is it? The nano-scaled materials are considered to be consisting of clusters of atoms, molecules, not the single atoms and molecules. As these dimensions matter exhibit novel properties such as they can be used to improve the existing materials as well as to produce new materials with expectational properties. As the nanomaterials of the size resembling that of largest molecules present in nature such as proteins, DNA, etc., they can be integrated into a device to interact with these molecules. Physics at nanoscale. Owing to the nanoscale dimension, nanomaterials are dimensionally more closer to individual atoms and molecules than the bulk materials. Quantum mechanics is a significant model employed to describe the motion and the energy of individual atoms and electrons. The quantum effects and the properties relevant that nanoscales are described below. At the nanoscale, the electromotive force dominates where the gravitational force is negligible. Since the electromotive force is independent of the mass of the particle and is determined by charge and the distance of the particle, it is strong even for nano-sized particles. Wave particle duality. For small objects having lower mass such as electrons, wave nature became predominant. Thus, the electron exhibits wave-like properties and its position can be described by wave probability function. Tunneling. Tunneling is an extremely important consequence in nanoscale materials. As per classical mechanics, an object can pass a potential barrier if its energy is greater than that of the barrier. Thus, if the object has energy lower than the barrier potential, the object cannot cross the barrier. In this case, there is zero probability of locating the object on the other side of the potential barrier. But as per the quantum mechanics, the object can tunnel through the barrier. Also, the thickness of the barrier is crucial in determining the tunneling probability of particles. As the thickness of the barrier should be of order of particles wavelength, thus even if the object's energy is lower than the barrier, there is finite probability of locating the particle on the other side of the barrier. So this is the tunneling effect. So in quantum confinement effect, the nanostructured materials including metals, electrons are not free to move within the material but are confined in space. In the bulk matters, the bands are actually formed by merge of adjacent energy levels of large number of atoms and molecules. So you can see the diagram picture here. As the particle size reaches the nanoscale, the number of overlapping orbits or decreased or the energy level decreases and the width of the band gaps gets narrower. That is, the width of the band gaps get narrowed. You can see. This will cause an increase in energy gap between the valence band and conduction band. Therefore, there is a high energy gap in nanoparticles than the bulk materials. The band gap is the region forbidden for the electrons. The larger the forbidden region, greater will be the restriction on the movement of electron. The electrons are thus confined in space and are not free to move. This effect is called quantum confinement. This affects the optical, electrical, and magnetic behavior of materials at nanoscale. Thank you.